I'm really excited to have you all here. We're going to jump into the content and walk through the Architect's Guide to Conscious Material Selection. I'm really excited to be joined by Erin and Elizabeth, who are definitely the subject matter experts. They're going to be walking through the content today because I I'm excited by the partnership that I've had with the AISC. They've actually sponsored season 4 of the Growth Tech podcast. And just in this process of jumping onto calls with them, promoting some of their content, I've learned so much about conscious material selection, about materials in general, about sustainability that I am sad to say I did not know at all. And I feel like I should have known because, just like any trained, anyone that's trained in architecture, I have a couple of degrees. I practiced for several years, and uh, I was completely, I was completely apparently lost on these details. So I'm really excited for you all to jump through it too. But maybe you are like me. So before we jump in, and before Erin and Elizabeth jump in, curious on a score of like 1 to 10, just drop it, or not 1 to 10. Let's say 1 to 5 in the chat. How confident do you feel today in your sustainable material choice, in your ability to make sustainable material choices for your design? 1 being not confident at all, and 5 being super confident. Esteban's above. He's above 5. He's at 7. 1. Ben, I'm gonna be right there with you, man. Now I am. I think before I saw this, I would have thought maybe it was 3, but after seeing it, I was like, oh, never mind. I might be closer to a 1. Um, but Erin and Elizabeth, please take it away and introduce us a little bit to what we're talking about today.
Yeah, so I'm going to introduce myself. I'm Elizabeth Lapira. I was practicing architect for 12 years prior to joining AISC, about a little over a year ago now. So AISC is a not-for-profit technical institute that's existed over 100 years. So it was started in 1921, and it was established to provide data and resources for the AEC industry. So building on that industry, they started the Architecture Center in 2024. So this was a digital online center for resources for architects created by architects. So it's an initiative that was formed to inform, engage, and inspire architects. And I'll turn it all over to Erin to introduce herself.
Yes. So Erin Conaway. So I am a licensed structural engineer. So kind of on the other side of the room. But I am AISC Senior Director of our Building Initiatives program. And that includes Architecture Center as well as various other national programs that help support different sectors of the building market. Designers and contractors, as well as some support specifically for emerging professionals. So yes, we're excited to build on our 100+ year history of providing support for AEC to provide support specifically tailored to architects. And thank you for having us. We've enjoyed partnering with Growth Tech this fall.
For sure. Yeah, I'm super excited about this. And just before or as you start jumping into it, I'll just let everyone know here, if you have questions, if you have comments during the process, either drop them into the Q&A or drop them into the chat. I'll be monitoring and kind of jumping in and interrupting Erin and Elizabeth as we run through this process with any questions that you do have. But if you're anything like me, after seeing this run through the first time, there's going to be a lot of questions coming through. So don't be hesitant to drop them in there. And I will, if it's okay with Erin and Elizabeth, not be shy about interrupting.
Yes, please do.
Cool.
So we'll go through, because this is a continuing education course, we'll just go through the slides that we have to show. It's been approved for AIA credit. And AISC is a licensed and approved provider for AIA continuing education. A few of the learning objectives we're going to look at is sustainable design principles, analyzing and interpreting material life cycles, environmental certifications, and then incorporating conscious material selections. So we represent the structural steel industry, and we use steel for the more in-depth examples, but we'll also be discussing topics in relation to concrete and wood really for one simple reason: we don't build with just one material. So all materials are interdependent, and thus we can only achieve the ultimate sustainability if we fully understand the opportunities that all materials can provide for use on a project. So we will review the life cycle of materials, opportunities for improvements, environmental product declarations, can designers do, and then questions at the end or throughout the presentation.
Okay, so we always like to start out talking about why we are out talking to architects and designers about this. As I know, everybody I'm sure on the call realizes kind of our most prominent measure for how we're doing in terms of design is global warming potential, or GWP. To become very commonplace now in our dialogue in the AEC industry. And, you know, the buildings that we design and that we build really impact every sector of GWP component throughout its life, from the initial stages of product manufacturing and production through design and construction of that project, through operations, and then what happens to a building at the end of its life. So there's a lot of materials on the building. Not all of them are materials that we'll be addressing specifically today. But today's presentation focuses mainly on structure. And why? Because structure offers a big opportunity. So this presentation, we're talking mainly about the superstructure and the foundation, which includes, vertical framing, horizontal framing, and then any of the subgrade foundations you have. And depending on what type of building you have, really structure can contribute up to 50% of the carbon impact of a building. So it's a big chunk of the puzzle, and mainly the focus of our presentation today. So a life cycle assessment, also known as an LCA, is a systematic analysis of environmental impact of a product, material, or process during its life cycle. And there are various stages of a life cycle assessment. And at the end of a product life, or we'll talk about building here in a moment, there are various options for how end of life management, from most preferred, either reusing material in its same form, all the way down to a least preferred, where it's being landfilled. So I think with anything, what we use in our household, the materials we use in design and construction, we want to make sure that we are trying to avoid that least preferred end of life scenario, which should be landfilling and creating waste. Life cycle assessment is a very scientific process and governed by several international standards, notably ISO 14040 and 14044. So a whole building life cycle assessment is the preferable method for when you want to measure how a project or a building can impacts the environment from the beginning stages all the way through its end of life. So typically in practice today, a WBLCA includes 4 stages: A, B, two stages and 2 modules in a B, and a C. So kind of 2.5, I guess. But so module A definitely deals with the product manufacturing or production. It's important to note that for different materials, the point of manufacture can be confusing, and it does differ between material industries. You have your construction module within the A stage. You have your maintenance and operation of the building, and then again, the end of life and what happens to that building when it served its lifespan and served its needs. There is a 4th stage, which talks about beyond kind of the end of life. That's not typically considered in a WBLCA in practice today, but as an industry, it might be in the future. And there are various organizations like Carbon Leadership Forum looking at how you would do that and the implications of doing that. So because we are steel people, we are going to kind of fall back on a lot of examples and show you a lot of data when it comes to steel, but we're also going, like Elizabeth mentioned, show you the data, some of the data that exists for wood and concrete primarily, just so you can get an understanding of kind of where the major contributors are for the material and where the opportunities lie for each of the materials. So for the product stage of hot rolled steel, so hot rolled steel are your wide flanges that I'm showing here. So the most common section I think everybody's familiar with. And for hot rolled steel section, where that steel, those kind of that when I say raw material, I'm referring to raw beams that haven't had any labor go into them, that haven't been drilled or fit up. So those are produced at the steel mill, and it's really the mill that contributes about 90% of the carbon impact for a hot rolled section. Transportation of those raw beams to a fabricator contributes only about 2%. And the fabrication itself, which is oftentimes gets confused with the mill. So the fabricators actually are the ones that drill the holes and prepare the beam for your job site. So that only contributes about 8% to the product stage impact in terms of GWP. And so I guess the next natural question is why the mill impacts contributes so much impact to GWP. So the mill process is very energy intensive. About 85% of energy used in the steelmaking process comes from electricity. So over here on the right, and I'll go through these steps here in a moment, a large amount of that energy is used in what we call the electric arc furnace. And I'll show a picture here in a moment. And there is some like natural gas supply and other energy sources that get used in a reheating process. And I'll switch over to that picture now to show you what that looks like. But so the hot rolled steel that we use for buildings that are produced in the US, and kind of a fun fact, 90% is really the percentage to remember. So 90% of the impact comes from steel mill for hot rolled section. And about 90% of the steel that we use in the US today for building construction is actually produced in the US. So I'm not talking about foreign steel, we're talking about domestically produced steel. It's a very robust industry. It's something kind of a common misperception that steel isn't produced domestically, but is quite common in the building industry. And most of that, actually, say 100% of that steel comes from recycled scrap. So old, cans, old appliances, whatever, get shipped to the steel mill. The scrap is collected, melted down in an electric arc furnace. So it's really that second stage there where that bulk of that energy is used, like we talked about in the last slide. You can see kind of an energy charge coming down and melting down that scrap. That's then taken through a ladle refining furnace, where at this point, sort of like baking a cake. So the mill, has to add a little bit of this or a little bit of that in terms of additives to kind of bring the recipe up to the required ASTM specification, get the right chemistry. So then that beam runs through a continuous casting process where we form beam blanks. Those are cooled and then reheated, which is kind of the second source of energy at the steel mill. And then those beam blanks are kind of go through a rolling process where they come out as the finished product in various sizes.
Hey, Erin, can I ask a question real quick?
Yeah, definitely.
Now that you've got me thinking about cake, which is,
Yeah.
but I'm curious. I mean, you mentioned that 90% of the steel that's used in the U.S. is produced domestically. What's the primary difference between domestically produced steel and steel that's international?
Yeah. So this is called the electric arc furnace method of production. a lot of foreign steel is still produced in an old steel making process called the basic oxygen furnace, which it's a lot less efficient, and it uses a lot more virgin material. So the recycled content isn't anywhere near what we see in the U.S. For the more modern methods of steel production. And I think the number between, like, if you take China and convert it to U.S. steel, Chinese steel is like 3 times the GWP impact of domestic steel. So it's pretty significant in terms of the number.
Cool. Okay, thanks. Yeah. So it sounds like US we're heading in the right direction then for how
We
US
are,
is
yeah.
producing steel. Yeah.
And they've primarily been using electric arc furnace since about the 1960s, 70s. And it's a more efficient process. So.
Cool.
Okay, so we talked about the product stage. We're going to switch over talking about the end of life stage that you would see in a WBLCA. And like I talked about earlier, in general, in terms of an LCA, there are various end of life scenarios. They're typically the material can be downcycled, incinerated, or landfilled, or reused. So currently in the U.S., most of the concrete that is taken from an old job is downcycled. So about 75% it gets used as aggregate for future projects. It's also very important. It's just kind of reused in a different form. Today, about 58% of the wood get landfilled at the end of its life or incinerated. And as I talked earlier, most of the steel, in fact, 98% of the steel gets put back into the steel production process and reused as scrap to make new steel. So it's kind of recycled in its same form. There is a growing interest in reusing structural material in the same form for a future project. So taking members down and reusing them for a future project. And, I think there are a number of organizations starting to look at how to make that more feasible, which overall is good for industry in every type of material. If we talked about the product stage of hot rolled steel. So just to kind of give you a little bit of insight to the product stage of concrete, the largest CO2 or GWP impact comes from the creation of cement, the manufacturing of the cement. And it's about 40% of this is due to the fuel used for heating during that process. And about 60% comes from process emissions. So only about 10 to 15% of concrete is cement. The other various other impacts, but you are looking at really cement manufacturing as the biggest contributor when talking about concrete. And as I mentioned, at the end of concrete's life, about 75% of it gets ground up to make aggregate and used in roads or future projects. There is a lot of debate in terms of the wood product stage over stored embodied carbon. I guess, unfortunately, right now, with manufacturing processes, it's, using a finished piece of wood does not have the same amount of embodied carbon as a tree in a forest. So that's a common misperception as well. Just every material industry has a common misperception. So you remember carbon is only bad if it gets emitted into the atmosphere. So hence embodied and why we want to store that carbon. So if you have a tree in the forest, obviously 100% of that carbon is stored. Once that tree gets cut, about 46% of that carbon actually gets released to the atmosphere. Once it goes through the milling process, you have another 22% that gets released. You have about 32% stored embodied carbon from the original. During transportation, there's some impacts as well. So by the time a finished piece of wood arrives at a job site, it only has about 15% of the net carbon stored that compared to the live tree scenario in the forest. So so I always like to address that because I mean we feel strongly as with steel, with concrete, with wood. Our goal is to provide transparency and designers have information. But if we go to the base of where we're starting, we can't get better. And as Elizabeth mentioned in the beginning, I can't even think of a project that didn't use all of the materials plus others. And so the more we understand about where material comes from, the better opportunity we have to decrease its impact. And what we really want to move towards is a circular economy. So, there are a lot of organizations talking about how we can do this, and basically, the economy is how materials can be turned into resources for future materials, and avoiding the landfill scenario and the waste. So just to kind of, again, give you some numbers on steel, fortunately for steel, just by the natural created, it's a narrative, but if you'll remember right, or do you end up as
Hey, Erin, can you pause for a second?
Sure. Yeah.
Can
you hear me okay?
Yeah, it's breaking up a little bit. Elizabeth, are you getting that on your end too?
Yeah, I'm doing the
Okay.
same.
Okay. Is that any better?
Yes.
That is better. Yeah. Thanks, Larry.
Okay. I got the dreaded, your internet connection is unstable. Webinar, but
Zoom's always quick to let you know that.
Yes. You don't know exactly what the impact is.
Oh shoot! Now we're losing you again.
Yeah, we're losing you again.
Lose you again. Okay. Elizabeth, do you want to take over this slide?
Yeah, I can do that. So when we look,
then I can jump back in here.
yeah, sounds good. So when we look at the recycling of scrap, 92% of the steel, as Erin was saying, already existed as something else, whether it be old cars or refrigerators, demolished bridges. So because steel is 100% recyclable, we're able to reduce the amount of waste that is ending up in the landfill. So if you go to the next slide, I don't know if I'm going to have to share my screen too.
Yeah, we can maybe.
Yeah, I can.
Jump on.
There you go.
Okay, cool.
So if you look at a 5-story building, steel framed office building, it uses about 500 tons of structural steel. So that's equivalent to about 360 shredded cars, 122 old appliances, 65 tons of curbside recycling, and 79 tons of industrial scrap. So that saves about 11 million tons of carbon annually because we are recycling all that scrap material.
Okay. And I can try to jump back in here, Elizabeth. Yep. How do I sound? Okay.
So far, so good.
Okay. All right. It just, my internet needed a moment. So, okay. So I talked about the circular economy. We talked about LCAs, and there are various types of LCAs, or I guess I should say scopes of LCAs. So one would be cradle to gate, and that would assess the product from its creation and leaving the factory to when it leaves the factory gate. Cradle to grave would be from the creation of that product to the end of its life. And then preferably what fits into more of the circular economy narrative is the cradle to cradle, where you are tracking or looking at the impacts of that product from the time it's created to when it's put back into a process, and over and over again, creating that circular economy. So typically, today, a lot of LCAs either consider cradle to gate. For most buildings, we're looking at cradle to grave. And that would be those modules, the A, B, and C modules that we looked at earlier, as I mentioned. So when we don't have a circular economy, something we're all trying to avoid would be, like I mentioned earlier, landfilling material and creating waste, which has quite a significant impact, as you can see from this chart that was provided by the EPA, which looked at the demolition and construction debris generated in the U.S. between 2015 and 2020. You can see here metal, which would be our steel category, has very little waste, again, because of that 100% recycling, 98% reclamation rate of old steel being put back in the process. Wood, again, has about 20% of an impact here. Concrete, kind of the biggest contributor here at 50% of the landfill waste in the amount of concrete that was actually sent to landfill actually could fill 6 million dump trucks, which should be enough to stretch bumper to bumper around the earth 1.25 times. So very impactful, and something as an industry we all need to be aware of and strive to do better. So we want to move away from this kind of spiral effect of creating landfill and creating debris for future generations to more of that circular economy. Definitely don't want to spiral. So the good news is that there are opportunities for every material, and every material is getting better. So there are several companies looking at how to make better use of crushed concrete aggregates and carbon sequestering. And I think the biggest challenge for concrete is that its most beneficial qualities, which are durability and just kind of its mass, don't always contribute themselves to being able to be disassembled easily, to be reused in its same state. And so that's why we see a lot of it now being crushed up as aggregates, which is still better than landfilling, obviously. But as construction methods improve and the demand grows for more circular economy, improved construction and deconstruction methods will offer more opportunities for concrete as we move forward. In terms of wood and including mass timber in this category, currently there really aren't enough all mass timber buildings to have been able to take them down. So it's kind of hard to get an understanding of what would happen to mass timber at the end of its life. But the thought right now is that it wouldn't be able to be recycled easily because of the adhesives that are used and holding the various plies of the panel together. So obviously putting on emphasis on how to reuse the panels after the building end of life is the ideal goal. And I know woodworks and wood industry is making a push in that direction as well. Also, it's something that the industry is kind of pushing for is more responsible sourcing and more transparency and traceability of where the wood product comes from. Right now, we looked at kind of that tree example. There's also some confusion about the forestry of these products and where they come from. So it's kind of generally assumed that all of them are sustainably forested and these forests are sustainably managed, but that's not actually the case. And ideally it will be at some point in the future, but right now, kind of the wood that comes from the forest sort of gets counted as a net zero carbon impact, no matter where it comes from. So moving forward, I think that the biggest opportunity the wood industry has is more traceability and transparency in terms of where they're sourcing the wood and what the forest management practices look like. And so we'll hopefully see more of that moving forward, going forward. In terms of opportunities for steel, again, because it's a electricity intensive process, our biggest opportunity is the cleaner energy grid. And so these are various mills that we have in the US. You kind of see where they're located on the star on the map. And they each are looking at ways to provide cleaner steel by improving the energy grid they're pulling from. Nucor is probably one of the probably the biggest producer of steel in the U.S. And they pledged to reduce greenhouse gas intensity by 35% by 2030. Steel Dynamics, also a producer of that wide flange material, they pledged to go carbon neutral by 2050. Cleveland Cliffs is mainly a plate producer. They also produce items for the automobile industry, and they pledged to reduce GWP emissions 25% by 2030. And which is, these seem so far away when they first came out, but we're going to be there pretty soon, like 5 more years to go. Gerdau, another wide flange producer, has actually partnered with a power company and built a 80 megawatt solar field adjacent to its Midlothian, Texas mill. So looking at cleaner ways and cleaner energy is definitely where steel can improve. But we did get some good news this year. Our brand new data shows that the steel industry showed an 11% reduction in the embodied carbon of structural steel over kind of the last time we did LCAs, which is about 5 years ago. So kind of some numerical data for how we're improving as well. So I mentioned this earlier, stage D of a WBLCA, what happens beyond the life cycle that we're looking at, and the Carbon Leadership Forum, in conjunction with some other organizations and companies, recently put together a report last year looking at just that. So the two main goals of the report were to improve end-of-life modeling in WBLCA tools and to explore opportunities for developing more of an open access EL database, all in an effort to understand how activities in stage C influence stage D and vice versa. So there are a lot of different tools for WBLCA. We don't recommend any certain one. The steel industry doesn't have any, but there isn't a lot of, it's not like the Wild West. There's not a lot of industry guidance, I guess, or recommendations for how to use the tools or which tool to use. So our main thing is just try to understand the data that the tool is using. And a good example for us, the challenge that we face for steel is that, as we asked about earlier, Tyler, not all steel is produced in the same way. So steel coming from China has different, more significant negative impact than steel produced in the U.S. And we do find that a lot of these tools actually mistakenly pull world steel data. So you're trying, as a designer, to get an understanding of the impact of the project and the materials you're actually using, but you're kind of unfairly being punished with using the data that comes from materials that you're probably not going to end up using on your job. So it doesn't give you a clear picture of where you're at. And then again, if we have a clear picture of where we're at, we don't know how to get better. And then another challenge the wood industry faces is just, again, the sourcing of where that material comes from and the tracking and the transparency there. There's some confusion. So both of improving where we get our data and understanding what the data is telling us, and the data in the product or the actual tools that you're using is the most beneficial takeaway, I guess, for this audience. So with that, I'll hand it over to Elizabeth to understand how to better understand the data that you're using for your project.
Right. So, in understanding the data, most of you have probably already heard about the Environmental Product Declaration. It's the standardized document for reporting the results of the LCA. So, the way the data is typically communicated is through these EPDs. It's kind of like a nutrition label, following that baking a cake, following nutrition labels so that you know where your direct material has inside of it as a product. So It allows us to do two things. We can compare the carbon footprint per unit across two equivalent products, and then we can also compare carbon footprint with third-party targets. So a lot of these EPDs consist of manufacturer company information, product identification information, data on the raw material that's used, and the content of those materials. So we can talk about the types of EPDs. So we have industry-wide EPDs. So this represents your overall impacts for a range of products within a group of manufacturers. If you go to a more detailed would be the product-specific EPDs. So this represents the impacts from a specific product, but it does encompass manufacturers across multiple facilities. And then if we want to get even more specific within these product specific EPDs, there's facility specific EPDs. So this allows us to understand exactly where that product's coming from and the manufacturer that did it. So as we said, when we are adding ingredients to make those steel members, they can slightly range in their product information. And so that's why facility specific EPDs are really important. Um, so facility is what we talked about is the mill, and the EPD that's facility specific was actually introduced with the Buy Clean California Act in 2017. So if we look at the different tools, and Erin touched on this a little bit, there's the standalone programs versus embedded programs in a modeling software. And some of the standalone programs often used by like sustainability consultants are a little bit more specific and more accurate from where their data is taken. And of course, you still need to check those numbers to make sure that they're pulling the right information for your specific region or your specific project. Whereas the embedded software often uses like general overall data. Um, as Erin said, pulling maybe world steel data instead of pulling product specific for a domestic. So if you're building in the US and you're getting world numbers, your information is often going to be inaccurate. So EPDs for concrete. So concrete can also get pretty specific. The issue with that is that concrete, there's so many different types of concrete and so many different people producing concrete. So although they're doing better and greatly improving the number of EPDs they just have so many plants to pull that data from. So getting those specific numbers are harder within the concrete industry. So as you can see in the chart, the orange is the number of US plants or US companies or US plants and then the blue is the number of EPDs specific to those companies. So they're pulling a lot of industry average, but only about 10% represents like the specific concrete. And for the wood industry, so the American Wood Council and the Canadian Wood Council have issued industry averages for North American wood products. However, the majority represent light frame wood products. They are product-specific EPDs for mass timber for some manufacturers, and those are available on Woodwork's website. The thing to keep in mind is something that Erin said earlier, is that there's not really consistent data on the sourcing side or the upstream data. So the assumption for almost all of these EPDs is made that it is coming from a sustainably harvested forest, but they do not specify the forest. So that's where that assumption kind of can trigger some issues, because if you don't know where the forest, then you're not confirming that sustainability. EPDs for steel. AISC produces series of environmental product declarations for the different types of fabricated structural steel. So hot rolled sections, hollow structural sections, and steel plate. So these are the industry average EPDs. So because 90% of that GWP impact comes from mills, that's what these EPDs are focused on. So they show the industry average for across multiple mills. When we're getting, again, more specific, we want to look at those mill facility specific EPDs. So these are about the product, and then they also tie back to the mill where that product was created. So 100% of all the domestic structural steel is tied to a mill specific EPD. So of course, 90% of those GHG emissions come from mill. Very little comes from that fabrication process. So that is why the mill specific EPDs are important when you're talking about LCAs. And then why are we talking about EPDs? Most of the new certifications for sustainability are turning to EPDs in their rating system. So LEED is now using EPDs to contribute to the material and resources category. BREEAM and Green Globes also uses EPD data to assess the environmental impacts and sustainable performances. So the benefits of using these is it helps overall environmental footprint of buildings and contributes to higher LEED certification levels when you're using very specific EPDs. So this chart that we're showing overlays the goals of the AIA 2030 commitment for operational carbon intensity based on the 2030 challenge, and the structural engineers SE 2050 for the structural embodied carbon. So showing the relative magnitudes and reductions through 2050. So AISC has been part of that SE 2050 commitment. So that it's part of the organizations committed to lowering that embodied carbon footprint. So understanding the background of where these emissions come and how to read EPDs is becoming even more important as the regulations are changing. So many of you may have already heard about Buy Clean, but it's a movement that advocates for environmental policies and encourages the use of products and materials with a smaller carbon footprint. So Buy Clean mandates the use of EPDs, and the 5 states that are highlighted in green already have it into law. 12 other states are considering it, and to bring the Buy Clean Act into law, including the federal Buy Clean, is also being considered. So these organizations listed are part of the group that has been leading that charge. AISC has been involved in educating lawmakers on the specifics of the steel industry and carbon accounting. So we want to look about what can you do as a designer. So we all know that if you don't build the building, that's probably the most sustainable building. However, there are things we can do as designers. So selecting salvaged or refurbished materials, design for disassembly and deconstruction. So in the case of steel, bolted construction versus welded construction. Design for flexibility and adaptability. So on the right, Blue Cross Blue Shield building in Chicago was originally built in 1995. But from 2007 to 2010, it underwent a vertical expansion of additional 30 floors. And that was pre-planned during the 1995 design. And then when we talk about reuse and retrofit, adaptability. So look for materials or combination of materials that allow for that adaptability. Can the existing building areas be subtracted to accommodate new use? And can minimal structure be added to accommodate for lateral bracing and resilience? Can floors be added to an existing building with minimal foundation additions? So as an example of steel has a high strength to weight ratio, so it can play really nicely with other existing materials such as concrete for additions to existing steel buildings. And understanding the different advantages each material can bring allows for greater flexibility. So when we're talking about deconstruction, there's a great case study in Boulder, Colorado. It's the deconstruction of City Hospital. And we do have that case study on our website. But Some of the beams and columns were reused, and other members were able to be prefabricated without being melted down, so reducing that electrical cost. And then this ties back to circularity because structural steel has that 98% recovery rate. Um, and when we're talking about the reuse of those beams, the 25 tons of salvaged structural steel was reused in Boulder's fire station number 3. And those members that I just mentioned about the Boulder Hospital, some of those members were used in this project. The design team was Davis Partnership, and the engineer was KLNA. It was completed in 2024, and KLNA was part of the hospital deconstruction. So they were alerted during the schematic design of this fire station that the project team was able to reuse framing from the deconstruction of the hospital. There was uncertainty about the project schedules and whether they would align. So to hold that possibility, the structural drawings provided both new specifications and then also specifications for the salvage material. KLNA also specified and managed the careful process of the deconstruction from the hospital. So they were able to catalog, stockpile, and test the material. And many of the coatings had to be removed for each piece of those reused members. But each of the deconstructed material had its own cut sheet, including a picture, dimensions, and additional details. So this project had the advantage of having a team that was on both projects in order to make sure that they were categorizing each of those members. The additional labor associated with salvaging the steel meant that those cost savings was insignificant, but the value laid in reducing the embodied carbon of this project. So the other thing you can do is leverage your specification. So request EPDs, as we talked about, industry-wide is good, but facility-specific is better. Asking for supply chain transparency, evaluate cost and carbon in the bids. And then specifically to steel, if you use high-strength steel and bolted rather than welded connections. So again, we understand that you're not going to build a building with just steel and ignore all other materials. So we wanted to create a design guide that blends the sustainability characteristics of both steel and wood and uses both materials to their advantage. So AISC created the Design Guide 37, which provides a multidisciplinary review of the design considerations that impact structural design of the hybrid steel frame structures with mass timber floors and include fire, acoustic, and sustainability information, all within this design guide. And for architects, we took it one step further and created the Hybrid Steel and Timber SMART reference. So it takes the information from the design guide and reduces it down to key highlights key information from that design guide that's specific to what architects need when designing. So no matter which material you're using, we encourage that you engage with industry experts, ask questions, and then request that transparency for your materials. Our sustainability team has been creating new resources specifically for both designers and owners. So EPDs, those are available on our website. We have a designer sustainability resource toolkit, sample specification language, and then also owner's resource toolkit to help you talk with your owners about sustainability. And there is a design guide that is expected early next year to add to this toolkit.
That was amazing. You know what's funny? Every single time that I thought about asking a question, because I have a copy of this this over here, I was like, never mind, they're gonna answer it in just a second. That was so great, Erin and Elizabeth. Thank you both so much. And while we're chatting, if you have any questions, don't be afraid to drop those in there. I mean, my first question is, can you drop a link to those resources you were just talking about at the end, Elizabeth? You were kind of like holding those out because that I feel like everyone, I don't know. I mean, my initial reaction to that was like, wow, I feel like what everyone should download right now.
Yeah.
Um,
Yeah.
so
We'll
it'd be
do
great if
that.
you could drop a link to that so that people can jump in. But um, what questions do you all have, or are there any questions from everyone here? I feel like that was super comprehensive. But Elizabeth, we were chatting before while people are dropping in any questions that they have. We had chatted before about how we felt like we had. I mean, you've been at AISC for a little while now, but like just in the last couple of months that I've been partnering with AISC, I feel like I've learned so much. I'm curious, what's the most surprising thing that you've learned since you jumped over to AISC?
I think like a lot of people, I had that concept about it was a dirty kind of industry in the
Yeah.
US. I didn't realize the amount of recycled content that went into structural members. I kind of just thought, oh, maybe 50%. And that's like a lot of times the number we get when we ask questions to architects, like how much do you think your steel member has? So that was a little bit surprising and kind of a good breath of fresh air to learn about that.
Yeah, that's I agree. I had the same immediate interpretation, but learning all these things has been amazing. Matthew, hey Matthew, do you have any other case studies that we can share with clients? Which is funny because we were just talking about that at the beginning, weren't we?
So we do have on the sustainability website, they have a few case studies on different buildings, but we also have case studies that we look at for presentations as well. So that is something that is available on our website. Are there's some printed case studies on different buildings. The one specific one on deconstruction currently, that's the only one we have, is of the Boulder Hospital.
Which is also a great example, by the way. And I have a follow-up question, I think, on that one. But first, let's go to Paul. So Paul was saying, have you looked into conflict-free building materials? That is, materials that don't have coerced or slaved labor producing it.
I don't, we have not specifically. I know that, I mean, it's definitely a valid question. I think what I understand in terms of the structural framing material that are used in buildings in the US, you're not going to run into that. However, I can't speak for finished material, um, like granite and things like that. I know for structural framing materials, we're not going to have that issue so much in the US. But yeah, definitely worth understanding for sure. Like
Yeah,
we
I'm gonna have to
said
go look
earlier,
at.
lots of materials and buildings. So
Yeah, yeah. Gonna have to go look at
yeah,
go look more into conflict free for sure. Thanks, Paul, for bringing that
yeah.
up to us. Um, Elizabeth, I was going to ask you because you had mentioned it just a little bit at the end there, but I thought it was such an important point. You were talking about the additional labor required on the deconstruction side um, of the firehouse building, and I forgot that you were saying it was basically insignificant relative to the cost savings. Is that what you said?
Yeah, so they saved costs on material because they were reusing the steel.
Yeah,
But as you heard, each piece had to have its own spec sheet. It had to
yeah,
have its own testing. So right now, that's where all materials are kind of running into issues of on the deconstruction end is making sure those existing members are tested correctly, and they can be put into a new building without any issues. So right now, that's I think part of the issue on the deconstruction end is because it hasn't been done that often. There's kind of lack of people doing it,
yeah.
and so there's not really that research on how to do those testings and how to bring them into the new building without labor.
I
Yeah,
see.
and
So
bold
your
and
point.
bold. Yeah. Go ahead. To,
Your point was just that it takes a decent amount of labor to do the deconstruction process properly as well, and so that's
Right.
something that for the entrepreneurs in the room, I know that we've got a lot of architects and probably some engineers in here too. It sounds like a good business opportunity. But Aaron, what were you going to
right.
say?
Right. I was just going to add that the goals for Boulder County definitely were more sustainability driven than cost savings.
Sure.
but yeah, they actually, I think, have a law in place that every building gets taken down, you have to try to reuse that material. But yes, it's a lot cheaper to just knock a building down than to salvage the material. So I definitely think it's a business opportunity.
Yeah.
Sure.
And we are seeing more and more jurisdictions starting to add more restrictions on just taking down a building. So that's also going to change the landscape is once it's required.
There you go. It always, unfortunately, it always takes it for it to be required, and then all of a sudden, all of the business innovation comes around it. So one step at a
Right.
time. Erin and Elizabeth, thank you so much. Thanks to everyone here. And then next steps on their certification for the credits. Yeah.
Yeah. So AISC, we'll go ahead and get those issued to everybody. And thank you for providing your permission during the registration process so that we can do that.
And if you have any issues or questions, you can email us at architects@aisc.org.
Perfect email address. Email the architects at AASC. That's the people that other architects want to talk to. Cool. Elizabeth, Erin, thank you so much. Everyone, thanks for joining us, and check out our calendars for future events. All right, thanks everyone.
Thank you.